Alright, so today we're going to start talking about rules for differentiation. So now we've done the really long way with the limit definition, such as f of x plus h minus f of x all over h as the limit approaches, for example, 0 or infinity or whatever number that we have, mostly zeros or infinities. And we've taken up almost an entire page probably for one problem. Well, now I'm here to tell you, guess what? There are shortcuts, and maybe you guys have noticed some patterns, and if you have, that's really great, and if you haven't, I'm sorry about your life. Alright, so rule 1, it says the derivative of a constant function, so it says if c is any constant value, then d of dx of c is equal to 0, so that kind of makes some sort of sense. The reason why that happens is because let's say I've got an x and a y, and then my particular value is just some constant number. Well, if I have a constant number, well, then my slope in this particular case is going to be 0. Alright, so let f of x equals 5. So I've got kind of like this graph just saying, hey, my y value is 5 all the way across. So find f of x. Well, my slope of that line would be just 0. Kind of nice. Alright, the next we have the power rule. So it says if n is any number, then d over dx of x to the nth is equal to n times x to the n minus 1, provided that n minus 1 exists. So the reason why this happens is, let's say that I've got this line sitting over here that we've known since Algebra 1. So I've got this equation of now y is equal to 2x plus 1. Well, we were told back in Algebra 1 that, hey, the number sitting out in front of x is my slope because that's my m. And we've been told that for a very long time. But let's say that I need to find the derivative of this. Well, finding the derivative of this, I would have to say, okay, well, I know that this is y, so y primed would just be 2, and that would be it. But using this little rule, because we can, I would have to say, okay, well, that's 2 times 1 that was attached to my exponent, times x that I initially had, and then I would have n, which is 1 in this case, minus 1 from this particular bit of the definition. Well, all in all, I would get y primed is equal to 2 times x to the 0 power, which is just 1. So all in all, I would just get y is equal to 2 times 1, which is all in all just 2. And this kind of idea works for parabolas, cubic functions, quintic functions, to the 19th functions, anything along those lines, but I wanted to introduce it very basically because derivatives are just slope. That's why back in Algebra 1, we could just say, okay, well, that's my slope. Cool. And that's the reason why. Yay, calculus. Appearing in Algebra 1. Alright, so now we get to apply this to f of x is equal to x to the 5th. Find f prime of x. I'm back on example 2. So I've got f primed of x should be equal to the number, which was my exponent, which in this case is 5, times x to the n minus 1. Well, n is 5 in this case, minus 1. So all in all, f primed of x should be equal to 5x to the 4th. And that's it. Alright, example 3, I'm still going to be using power rule. The reason why is because I am actually going to change this to being f of x is equal to x to the inner over outer. So I'm going to say 2 over 3. Alright, so now I get to go ahead and I get to say, okay, I'm going to take the derivative. So f primed is going to be equal to, well, I'm going to take my, what was my exponent, and put that out in front. So I've got 2/3, and then I've got x to the 2/3 minus 1. So all in all, that is going to equal 2/3 x to the negative 1/3. Well, we know back from Algebra 1, we couldn't just leave negative exponents. So I had to have 2 over 3, and then I've got now an x to the positive 1/3 in my denominator. And that's it. Unless you would like to change it back to radicals, because we started with radicals, so why not? So I've got 2 over 3 radical, I've got an x, I've got an inner power, I've got an outer power, and now I'm as basic as I can be. So, yeah. Alright, example 4, same type of deal, except this time I'm going to be kind of ahead, and I'm going to change that to a negative exponent. So I've got f of x is equal to x to the negative fourth. I need to find f primed of x, so then I'm going to have f primed of x. I'm going to take that number that was my exponent, put it out in front, so I'm going to have negative 4. I'm going to have x to the negative 4 minus 1, which all in all is just going to give me negative 4, x to the negative 5. And again, way back from algebra 1, I don't want to leave negative exponents, so flip over the line to change the sign of the exponent. So I get negative 4 over x to the positive fifth. And with that, I'm done. I will see you guys in my next video. It's getting long enough as it is.